What's going on? I want to show you a little app that I made using Plotly Dash and Pandas. Basically, my online banking service allows me to download my bank statements in a CSV format, and it just has the transaction date, the description of the transaction, and the amount, positive or negative number. So I wanted a way to just have a look at them, analyze them really quickly. I didn't want some big complicated piece of software to go through and all that. I just wanted a really simple thing I could throw the CSV into and start analysing my expenditures, just from some personal finance point of view. And at the same time, I was interested in learning Pandas and Plotly Dash, so I thought, let me create a little project for myself, and this is what I'm going to do. I'm going to make this so that it can be uploaded and deployed and running online. So I have deployed it on pythonanywhere.com, and the link will be included in the description and the readme file on the repo. But let's get on with it. I'll just give you a quick demo here. So we run it by running index.py. Okay. The structure of the Plotly Dash app is that you have a folder of apps here, the analytics and the uploading of the bank statement. In assets, we've got any images and a CSS file for the styling. If you're familiar with HTML, website creation and stuff like that, this will look really familiar to you. Data sets, I have a demo data set so that if the user doesn't upload a file, doesn't select a bank statement to analyze, it will automatically load a demo data set so that there's no error, and also you have something to look at to demo the features. And tools, this generate test CSV does exactly this. It creates the demo CSV file, so I can always generate new ones. And I've tried to include things so that if someone wants to download this and build it out into something else, there's some scalability here, and they can modify things and still test it and practice. You've got the main app.py and index.py. Okay, so we'll have a look at them in a second. Let's go straight into it. Okay, so I'm actually running it as a development server at the moment. Okay, that's what happens automatically when you run it. It's on a local network, and this is the landing page. Got a little link up here to go to my website, and as you can see, it says you can either drag and drop a file onto that button, or you can just press the button and choose a CSV, or you can go straight to view analytics. I'm just going to go straight to view analytics right now. And here we have the demo dataset being displayed. Really nice. If you hover your mouse over, you can see the details. And in the top left corner of the graph, you've got save snapshots. You can save an image of it. You've got all kinds of box selecting. I can just drag it like that and then press auto scale back to the original. You've got reset axis and a link to Plotly Dash. So yeah, pretty standard graph. And then we've got all our filters. Down here I've got a top list. You can change the size of the list if you want. You can have it top 10 or top 100. It's up to you. And you can also export them as CSV files if you want. The default is 20 when you load the page. And over here you've got your output. So you've got a little JSON output of the totals and the amounts here. You've got graph type selection. You can change it between funnel, line, and bubble. Bubble only works if it doesn't do it with paid in and out. So you need to have one or the other. So if I filter it by paid in and then click on bubble, then I get a nice bubble graph. Likewise with paid out. Okay. Now here I can filter by a date range. Very nice. And then I can further filter by paid in only or paid out. I can also isolate. So let's say we want to see Wells Fargo payments. Wells. Yeah. Oh, and we want Walmart. So I can just separate them by commas. Capital 1 as well. Yeah. Or I can choose to remove anything with, say, Walmart, shall we? Walmart, there, gone. Wells, let's go Wells, Walmart, capital, yeah. You can see how the filtering works. Clear date. And I've got this savings thing here because on my bank statement, the savings account number is obviously a payment going out because I'm transferring money into my savings account from the current account. This works just like isolate keywords, where whatever I put in, really, it's going to just show me the total here as savings. It's going to come up as savings, but there's no savings account in the demo set. So let's just say CVS payments, right? Let's type CVS into this instead of an account number. Here it's actually showing me the totals of the CVS payments. If you put your account number in there of your savings account, then all the stuff that go into your savings account will be displayed here. Okay, it was just a little feature I put in there for myself. Remember this, I started this to analyze my own statements for my own use. So there's that, and then there's a min-max setting as well. Minimum 100. Oh, say we're going out. Yeah, you know how to use this. Yeah, so let's say minimum 10, maximum 40. Yeah, so you can do all your analyzing on there. Get my bubble chart up. Do it for one date range there. Yeah, so yeah, that's the basic functionality of the app. Pretty straightforward, good stuff. Very effective, very useful. This is the structure that the data needs to be in. Date, comma, details, comma, amount, and then date, details, and amount. Okay, and if you don't enter a file with this structure in the upload section, then you'll get an error, and it will show you an example of what it should look like. So let's just say I delete that for now, and I go to load this file again. You see here, CSV layout should be date, details, amount, and here is an example. Bonus points if you can name the films these characters are from. So that's the functionality taken care of. What I'll do now is a little code review, go through some of the code for you. If you don't want to stick around for that, you can just go and either use the online app or you can download the repo and do whatever you want with it. Right, so a quick rundown of the code. This is the index.py that we run to start the app. Now there's a little comment here that says don't remove server in required import. Even though it's grayed out because we don't explicitly use it anywhere here, we do need it importing, okay? So we bring in the two apps, analytics and upload. We create a layout for the main app, which is basically just a HTML layout. Now, the way that Plotly Dash works is if you know HTML, it'd be really easy. You'll start picking up on the structure of things. These are just HTML elements that you add into here. You're basically just laying out a HTML web page. And the DCC are Plotly Dash elements. They're like Plotly's version of HTML elements and storage features and other interactive things, okay? Just go to the documentation and have a look if you want them all explained, but this is just a quick code overview, not a Plotly Dash course. What we're doing here is we're determining which app to display. When you first come to it, it's going to display the upload layout, okay? And when you've uploaded the file and you click view analytics, what it does is it changes the URL to this here /analytics, and this check if path name is equal to /analytics, it displays the layout within the analytics app. All right, and in the main we just run app.run server. So this is the actual app here. We have to set up any style sheets that we're using from externals for fonts and things like that, and pass them into the initializing the app. The same goes for these meta tags here. These are here so that it's responsive on a mobile website, okay? Right, now this suppress callback exceptions here, this is a really crucial piece because this is a multi-page Dash app, not a single page like you would normally learn how to do it. Now, when you're creating a page in Dash, you're using these layouts like I just showed you with HTML elements and Dash elements, okay? And the way that this system works is that you have a function here to change the page and react to data that the user inputs or buttons they press, okay? And the way that the callbacks work is they go by the element ID, and then you specify whether that element ID is an input or an output. So here I've got URL as an input, and the component property is the path name. So whenever you change the path in your address bar, it will check if that path name is equal to /analytics or not. If it's not, it will return the upload layout, which is the main page to upload a file. And if it is that, then it will return the analytics page. Okay, that's why all that the button does to go to the next page is just change the address bar and then it updates it. So now normally, in order for this page to load without error, all the callbacks would have to be present in the layout, right? But they're not going to be, because we're gonna load other layouts that have callbacks of their own in a separate PY file, like analytics and upload. These two separate layouts, and they've got their own callbacks here. Okay, so this is going to cause an error. But if we set suppress callback exceptions, then we just cut through all of that. We ignore it because we know what we're doing. It's intentional, and the page can load without error. Okay, suppress callback exceptions here for multi-page Dash apps, very, very important. They won't work without it. So the first page that gets displayed is the upload page. I've set the upload section up here, which is a dcc.upload element, and what this will do is allow me to store the data that you import from the CSV file. I'm going to process it in a particular way though. It has to be in a dictionary format. Okay, so we'll get to that. Telling it where the images are for the logo, for my company logo at the top. I'm setting up HTML elements here, so this is just text, right? Page body, landing page, bottom text. Okay, very basic stuff. And here we go. See, now if you know a bit of HTML, you're going to recognize this layout. This is just like writing div a, so html.a, html.div, simple stuff. href, children, html.image. Now what I could have done, say you put this in ChatGPT or something, right? This will actually change everything to have functions. It will have like, it will take all of this and put it in a function and return it as a piece of HTML. Say like prepare body, or create the logo header, and it will return the logo header bit. And in here you'll just call it create logo header, create body, create this. But I don't like that. And I know that it's good if you've got a massive project, you would split it all into functions or whatever, or even just constants like I've got here. What I usually do is if I'm going to split it up, I put it in constants, not functions. But having it like this just is really clear what everything does. You know, you've got your children here, class name for each row. You know it's text, div, link. You know what's going on, especially if you're familiar with HTML. You just look at it and it looks like a HTML layout. Okay, so not hard to wrap your head around. This is a hover image, which you can see there working. Yeah, and obviously I'm doing that using CSS, which we'll come to. So yeah, this is the main body of the upload page. As you can see, here they are, the tags, image, hover. Yeah, here's the circles that I've drawn using CSS. Here they are. These are the circles: circle inner, circle outer. So yeah, that's the circles there. And then we have the display page function, which is constantly being updated. So we've got select file, if there's no file, which is here. So select file there, see? So that's that bit. It's just returning what needs to be returned here, because we've got 1, 2, 3, we've got 4 outputs here. So we have to have 4 outputs here. Okay. Text status, data set, CSV output title, and CSV output. Now, when something is in there, we split the contents, right, so that we can take out what's been coming in. We've got input here, upload data, right? We verify upload, which is a function I've made. So this makes sure, first of all, that it is a .csv file. Then it converts the data and reads the CSV using the pandas command. And then we check that the header is correct, because we want date, details, amount at the top of our CSV file, remember? Date, details, amount. Yep, so we seek 0, set it to the beginning of the CSV file. of the data rather, and then we create the data frame. I made this function as well for that very purpose, because we're going to make sure we clean up the data set first. We want to make sure that any brackets in the details thing are taken away, because when we start filtering for things, this is going to mess it all up. Yeah, we make sure the amounts are floats and rounded to 2 decimal places. We set the date as the index of the data frame, and we send it back, and that all comes back to here in result. But then to store it, we're going to need to set it to a dictionary, right? And then when it comes back in the main application, we reapply the date index and stuff like that and set it back up again. And if all else fails and it's not correct, we display this example string, which is what I showed you before. Great. So let's move on to the main page, which is the analytics page where the graph is displayed. Get rid of this actually, there we go. Okay, so up here we're importing all these little helpers that I've got to help filter the data sets, okay? That's in this folder, this file here rather. And these commented out bits are the functions before I refactored them, just to show you the difference, because I went through all of this and refactored it all recently, considering I was going to make this video for it. And when I first uploaded it a while ago, I uploaded it as it was, the way I made it for myself to just work. Now, it's good to keep this like this, because then it shows you the process of, you don't just write out code and know everything straight away, especially when you're learning. And there's a lot of working things out, and a lot of the time what happens is you're writing a function to do something, and you're just trial and error, trying this, trying that, and you write all these lines of code, and then bing, it works, and you just leave it like that. You don't touch any of it. Like, oh, I've got it working, cool. And then you move on to the next thing, and then you've got this whole program that works, but it's not optimized at all. You've got loads of lines of code you didn't need to do because that was your working out. Well, now what you need to go through and tidy up all your working out into nice, concise bits of code. But then other people look at that code and they go, oh, how did he know how to do all that? How did you just know to do that? Well, you don't. You work it out. And then later you come back and you tidy it up, okay? So I've been refactoring everything, so it's quite a big file, this. But analytics, so this is the main page. We've got the default graph style up here, all these things that are going to be standardized, the default top 10 top list, the top 20 list, the demo CSV file, the datasets path. Okay, so I've done that backwards. I've gone up the list instead of down. Sorry. But so the data path, the default CSV file, the top length, graph style, page title. Yeah, so here we go. This is where I'm storing HTML snippets into constants that I'm then going to feed into the main layout, right? Once again, like I say, if you put this into ChatGPT, it'll give you functions and all this and change everything about, and it doesn't look the same, makes it much more complicated, yeah, to look at. Like I say, when you're used to looking at HTML, this makes sense. You can look at it and you can navigate through it. H3, H4, you know, their headers, input, instead of having an HTML input or whatever, you've got a DCC input. This is a pandas, this is a plotly dash input, okay? So each one of those obviously has a class name for the CSS, an ID, a type, placeholder, and then you've got your style for it as well. Sometimes you have to access the styles in line, sometimes you can do them in CSS files. It's very, very tricky. This was a lot of trial and error. What I would do to find out is literally open the analyzer here, and I would go through and say, like, to change the color of these so they highlight pink there. I go through and I'll find what is going on here? Why is this? Right. I'll go through here and I'll scroll through and I'll keep going down the list until I find the class names, what those are, right? Let's go back to here. Yep, see, we've got the inline FFA sort, FA sort up, that's that little button there. Path fill, there we go, that's where it is. So you can go through all the plotly dash elements and figure these things out for yourself. Graphs type div, you've got, there you go, button bar graph, you've got the class there, graph select button. Okay, and that's how I figured all these things out. And then I would go back into here, try and do them through the style sheet. If it didn't work, then I would go back into here and do them in line and it would work. So a lot of trial and error, a lot of messing about. The documentation for pandas only goes so far in the styling. Those little things I had to figure out and dig deep for. Maybe they're there somewhere, but it was long trying to find them. So here I'm setting up all the filter options. These are all the options, the inputs and the buttons that are going to be on the analytics page. The output box, which is this little JSON output box here. That's not formatted right. I don't like that. Why is that like that? I have to fix that. It's not in line. That used to... Oh, that was fine before I started refactoring things. I've obviously done something. I'm not happy about that. I get very annoyed by stuff like little things like that. I need to sort that out. Now I feel I'm annoyed by it now. Now the video isn't perfect. That's very annoying. But I'll sort that out. Anyway, here's the layout. So this is the dot layout, right? Analytics.layout. Yeah, we've imported from apps, from the apps folder. We've imported analytics. And we're in analytics, and this is the layout that it's referring to. And here I'm pumping in the constants from up here. Okay, so I'm laying out in the main div. There they are, main graph frame. We've got the main graph, and then we've got the right column frame. And this is what, these are all the options in the right column. Got the page title up here, dashboard title. Yeah, you see how it all makes sense? It's all legible. Top list, class name, table title, top list length input. We've got it all here, placeholder 20, because that's the default. Could have just popped that in there, but yeah. And then we've got table container, must be laying out the top 20 tables. And the main function, we've got a function here to clear the date range. Remember this one here, yeah? That's this. Determine figure type, so this determines what type of graph the person has selected. That's going to be used down here, and so is this. Apply filters to data frame. So I separated them out into functions, these things. And all this is going to do is apply all the different filters that have been selected in the right hand panel. You know, if it's being filtered by minimum, maximum, if it's isolating keywords or removing keywords, whether it's filtered by paid in or paid out or both. And here is the update graph function that is constantly listening for changes and constantly displaying the current graph. These are all the outputs, and these are all the inputs. These names here correspond with IDs here. Okay, that's how you get the inputs and outputs. It's because the outputs correspond with the IDs of the output elements, right? It's actually really simple stuff. It's genius. The way they've made this is so powerful. So we've got our inputs here. You have to have these inputs, but not that you use them, but it doesn't matter, but they're just part of the setup. So if nothing has been clicked or done, then there's no ctx.triggered, so we prevent update. We don't update it until there's any changes made. If there's no data, then we load the default data frame here in the demo dataset folder. And if there is an uploaded data frame, remember it came in as a dictionary from the upload DCC element, and we have to just quickly apply a couple changes here to set it back to the data frame that we had before. Okay, we don't need to do the bank CSV data frame because we've already done all those altercations. Now we just have to retransfer it back into a data frame, standard pandas data frame. Here we make a copy, right, and we call it the original data frame, so that if anything fails here, we just draw the original data frame instead, so that we don't have anything visibly breaking, where the graph is broken and nothing appears. That wouldn't look good. Okay, we wrap this in a little try catch thingy here so that we can do exactly that and return the graph using the original data frame if all else fails. Okay, and in here we just go through. We get the trigger ID. This is so that we can work out what type of graph the person has selected, okay, because there's buttons there, so that will be in the triggered array, which is prop ID. And where do we use that? All the way down here, I think. Yes, determine figure type. Yeah, so we've got trigger ID here. If trigger ID is equal to button bar graph, that just means that that's the ID of the HTML element, remember? Button bar graph, button funnel graph, they'll be up here somewhere. Boop. Where will they be? Graph type filter. Here, button funnel graph ID. See? So if any of these IDs are in the click catcher, when you click your mouse button on it, which is in the triggered array, we're splitting them all. We're splitting them, and we're getting the 0th index there. So that if you've clicked that button, that'll be the first thing on there, right? You've just clicked the button. So now that's what you want to do. You want to change the graph type, and that's what you're doing there. Okay. First of all, we filter by the date range, right? Because that's the most important thing. If you've selected a date range, you don't want any information from outside that date range. So we filter by the date range first. We come in, we get the date times that we've input, we create a mask, and we just apply the mask to the data frame, and we get back all the data within that date range. Okay. If it's not empty, we return it. If it is empty, we just return the original data frame. And then what we do is we calculate all the top payments lists. And the reason I do that before any other filters is because the top payments lists are static. They're the same. They're the top payments in the whole data set. That doesn't change. So I don't want it to keep changing all the lists every time you type in a new bit of input. We calculate top repeat. Why isn't it letting me control click? There we go. So calculate top repeat transactions. We've got a sort by duplicate count with totals first. So this takes in the data frame. It groups them by details, sums the amount up for each group, and counts how many duplicates, because we only want repeated payments. We want the totals of the most repeated payments, yeah? So we're going to do that. We're going to get the sum, but we're also going to add a column called count. Okay, we're going to change it to count at the end, and then we're going to pass it back. Top single payments in, calculate top single payments. Now we get the duplicates again this time, but then what we do is we filter the data differently, so we get the single payments. Okay, and yep, round them down, put the minute in or out, and send that back. And then we've got here the data frame to table, so that we can display it in the HTML elements. So top repeat payments table. Here, look, we're returning a HTML setup there, a data table with its styles all here. Okay. Now what you can do here, I've commented it out, is you can define all the styles here. See, style data, style header, and style cell. And instead of having them here, data, header, and cell, you can just use the unpack key ** table style, and it will go through and unpack those values and put them in. You could just delete this, and then you could change it all there, but this isn't a big thing. I like to have it just here. It's not that complicated, is it? So just to show you that you can do that. Okay, so we create all the tables, and then we create the titles. Right, so that's all done, that's all ready. Now we apply the rest of the filters, yeah? So these are the other filters, as I've shown you already. Isolate, remove, min, max, in, out, yeah? And then we get the figure type, as I showed you previously already, and balance output. This is update JSON output. So this is to update the little thingy here where my isn't in line. Which is highly annoying. Right, I see what's wrong here. So what we want to do is we want to actually take indent off here, because that's what I've done. I need to put that in here, I think. That should resolve it, actually. Let's see, shall we? Yeah, sorted. Okay, so format JSON output. Underscore in front of a function or a variable means that it's private. This means as a function, it means it's only going to be used within this .py file, right? It's only going to be used within this module or class or whatever. Same if you put an underscore in front of a variable, it means it's only going to be used within that scope. So yeah, that's all that means. Okay, so we've got an indent. So we just append the arguments in here we're appending them to the new line underneath the open bracket, and we're putting an indent before the label and the value, okay, because the label and the value come from an argument I+1. So we come in, we format, we strip it, and then we add this at the end, and we output the formatted thingy-majiggy-bob, update JSON output. Get the calculated totals in here. Yeah, here's the total calculation. Data frame locate amount less than 0.sum, greater than 0.sum, rounded to 2, and back we go. Yep, we absolute value them, so we don't have negative numbers and positives, we just have integers, floats rather, to display. And we then check if there's a savings, that savings bit that I showed you, which is just isolate keys, as you can see, isolate keywords, and then we calculate the total of the savings, which isn't necessary. It shouldn't really be named savings here because it can be anything. It's just a way of isolating. I guess it's isolating totals, isn't it? Because it doesn't change the graph. It just changes the JSON output. But I've called it savings because it was for my personal use. And it was just the only reason I thought of this feature in the first place was because I wanted to be able to have a readout of what my savings were. And I didn't want to make a really complicated program where you had to specify all these things as a user and say, this is my savings account file, this is my this file, and that's that file. I just wanted a way to analyze the data quickly and easily, yeah. Again here, I'm bubbling up errors, propagating errors back up. I haven't put all of these in try catches, I've just put them in one. Yeah, because I'm just going to catch the exception and it's not a big deal. Once again, if I was doing something for production, this would have error logging and there'd be error logs and things like that, and I'd have a proper way of displaying the errors and handling them, but that's not what this is. It was just an exercise for me to learn pandas and stuff. So, right, so then here we have the graph. We make the graph, new graph here, new graph. And this is where I make the graphs. I've got common parameters here for all graphs. The Y data and the X and Y data is always going to be the same. Hover data, which is when you hover your mouse over the graph, what data it displays. You can set that here. It just pulls the data out of the columns. And I'm using Plotly Dark. And if the graph type is line, I make a line graph. If bubble, I make a scatter graph. If funnel, I make a funnel graph. The default is a bar graph. And we graph new.update layout, okay, and we just pop in the graph, a style which has been passed in here, graph style, which is here, yeah, sorry, not there, it's a constant. Oh, there we go, there's the style up there. And that's pretty much it. So this is before I refactored down here as well. See, I had this is me working it out, right? This is me trial and error, putting things in, got the data frame sorted here, but then all these filters here are just being applied. They're not separated into functions. They're all in it's all one long function. Filter by keywords, isolate. So all I've done is go through and separate them into functions, right? The graph style, I've used it up top as well, so I just made it a constant. Got the returns here. It's all the same stuff, but I've just split it into manageable functions, and then within those functions you can have error handling and do better checks. Otherwise it turns into a big mess, okay? I'm going to delete all these comments when I put them up into the repo because it's just too much of a mess and too much that can go wrong. It's unnecessary. As you can see, so here was the graph, new graph function before I decided to go, okay, I'm going to collect out all the stuff that's common here and just pop it in a little dictionary there. Okay, see how much that improved that? So we don't need that anymore. And in calculate total as well, I've added some error handling here. As you can see here, I've narrowed this down to just 2 lines from 3, and I'm using absolute here to get rid of any negatives. We've got it all rounded to 2 here. We've got the sum in one line instead of having it separate. Same thing for input, yeah, total in rather, should I say. So yeah, just streamlined it a bit, added a little doc string and put some error handling in. That all works nicely. Lovely jubbly. Fill bank owned payments, pretty straightforward. I don't think I can streamline that anymore. Another one I'll show you, I didn't keep all the old ones, but another one I'll show you here is the JSON, update JSON output that we just went through very briefly. Yeah, so what I've done here is streamlined again. Here this is me working out how to get the string to look the way I wanted it to. So this little function here, format JSON output, previously was just line by line building the output string line by line manually, you see? So it doesn't just come out like that. There's lots of trial and error here, look. Yeah, and I just refactored that, split the formatting into a helper function. This is another one that was streamlined nicely. Calculate top single payments, yeah? This was the original one. As you can see, pretty gnarly. This is me testing things out. I've got a little warning here. Basically, I tried to make the format of this have commas in it, you know, to format the amounts like currency. But when I do that, this filtering here gets totally messed up. It can't filter it with commas in it. So there's probably a way around that, but wasn't necessary for me to waste time fixing it. Anyway, that's about it. This is the generate test data set. All it does is, like I say, generates a test data set, but it does it in a way so that there's at least some single payments and multi payments, so that everything can be analyzed and found. Okay, so I've just spotted a problem that if there isn't any single transactions, or there isn't any multiple transactions, it actually displays the error here and doesn't go away even though it works. So I've just got to fix that. I'll tell you what I'm going to try and do is here, just send back a empty data frame, and same here. Okay, let's see if that fixes our little problemo. Okay, now if I select this one shouldn't, I don't think this one will have any singles in it. So we have no single stats here. Perfect, yeah, it does work, good. Okay, so yeah, I fixed that now. All I had to do was return an empty data frame so that down the line when I go to make the table and it's expecting that data frame to dict, it works. Okay, even though it's empty, it doesn't cause any errors, and we're good to go. And that's that. I'm now gonna submit this, push this to the GitHub repo. I'm gonna update the Python Anywhere link, upload the video, and it'll all be good to go. All right, thanks for staying tuned, and until next time, see you later.